So today we're gonna discuss about those artificial satellites. So before moving ahead to discuss about what is artificial satellites, let's just examine that what is exactly mean by satellites. What does this term mean? We're gonna discuss the two terms together, but first of all, we're gonna discuss that what does it mean? Do you know what does it mean, satellites? Okay, so the question arises that what are satellites? Okay, so the satellites are the object that revolves around Earth. Satellite, satellite. Okay, wait. Mm, Satellites are the object that revolve that revolve wait, around the Earth, right? So anything or any object that revolves around the Earth is a satellite, right? So any object or anything that revolves around the Earth is known as satellite. So satellite can be of two types. We know the satellite is of two types. Let's just get the sticky notes for writing. Let's get a sticky note here. So satellite satellite is of two types. The first is artificial and the second is natural. Okay, so satellites of two types. The first is one is artificial while the other one is natural satellite. If we talk about the natural satellites, we know we are all are aware that every planet has its own natural satellites. That is, um, wait, which is moon. Moon is a natural satellite. Moon is basically a natural satellite because each planet has its own satellite or anything that revolves around the earth is known as satellite. If we talk about the artificial satellite, there are a lot of artificial which is launched by us, which is it is launched by us. It is launched. Okay. So now we're gonna discuss about that what is artificial satellite or let's start it from the scratch that what exactly it means. It is launched, right? So it is something that we launch is known as satellite. So one thing that you need to keep in your mind while dealing with it is that we have two types of satellites. The satellites is of two types. The first is artificial satellite, while the other one is natural satellite. So first of all, moving ahead to discuss about artificial and the natural satellites, let's discuss about the Newton's view about the satellites and the launching. So if we talk about the Newton's point of view, we're talking about not about the recent century, which is 19th century. We're talking about 17th or 16th century, and there was a no concept of. If we talk about 19th or 16th century, there was a no concept of the satellites, which means you're launching your satellites through rocket because we are known that the satellites are mostly launched through rockets. So if we talk about Newton's concept, so he actually did the experiment. First of all, he did not do the experiment. It was something which was um, a thought experiment that he did, though it plays a very important role because most of the satellites are being thrown through this process or through this phenomena. But we want to talk about that what exactly a Newton is. A Newton satellite, which means the Newton satellite was unpowered. First of all, that you can keep in your mind is that Newton satellite was unpowered. Unpowered. Right. Now, what does mean by unpowered and powered? Let's just discuss it. Unpowered. And the second one is powered. Yeah. Okay. So let's discuss that. What is unpowered? First of all, unpowered. Then one is powered. If we talk about the now the satellites that we have today, which is it has been evolved. This is evolved, very advanced satellites that we have been launched through rockets. Actually, a consecutive force, a not consecutive, continuously a force is acting upon, which means the engine thrust is continuously responsible for the rocket motion or the rocket, and the hydrogen propulsion is used in the rocket just to send it from the earth, from this earth to the to launch through a certain to launch a satellite because satellites are inside the satellites are launched through rockets, right? So it needs hydrogen propulsion or a hydrogen fuel, and the engine thrust is acting upon the rockets. But we talk about unpowered, so it has no force is acting upon. For example, let's consider the example of gun. That's an example of gun. So we know that when you fired a bullet from the gun, only once the velocity is needed to fire the gun to fire the bullet from the, and once your bullet is fired from the gun, it does not need a consecutive not consecutive, but no continuously no force is acting upon this bullet just to make it in a motion. Okay, so once the velocity is applied and it's moving without any external force acting upon it, only once external force is acted and through which it's fired from the gun, but bullet is fired from the gun, right? So actually, this is unpowered and this is powered. And if we talk about Newton's concept, we talk about unpowered, not we talk about powered. So let's discuss the first of all, we're going to discuss about the Newton thought experiment, right? So let's just erase it. Newton's thought experiment. Okay, so we can bring a picture here. We can bring this picture here. So what does Newton did is that, let's just increase the size of this picture. So for a need, I need a dark ball so that it will be prominent. For example, this is a ball. So what did Newton suggested? First of all, let's read this theory. What it says? It says that in 17 it says that in 1728 I finally published my thought on. This is said by Sir Isaac Newton. What I came to call gravity. The question was whether the falling bodies on Earth were controlled by some mechanism that kept the planets in orbit. Galileo thought not. But I came up with a simple thought experiment that indicated that they can have the same phenomena. Right? So this is said by Newton. And what does it mean? Let me just discuss it here. Right? So for instance, now this is a ball and it is fired with a certain velocity. And when it is fired, for example, first of all, it is fired with let's take a dark color for it so that it will be prominent. So first of all, it was fired with, for example, for a while, consider it that it is fired with 10 kilometer. And Newton said that when he fired this cannon, first of all, it's a thought experiment, thought which means thought cannon experiment. The fall, there was a curvature and eventually fall toward the center just because the force of gravity was acting upon it. Then he launched the ball with 20 kilometer. Let's say 20 kilometer. Let's say 20. And when he launched with a 20 kilometer, it follows this elliptical path, curved path, and curvature becomes smaller and then eventually falls inside the Earth's surface. But when it was actually launched with 7.9 kilometer, which means wait, when it was launched with 7.9 kilometers, 7 point when it was launched with 7.9 kilometers, 7.9 kilometer, when it was launched with 7.9 kilometer. So this is basically a ball and then it started revolving around the Earth's surface because now this is a velocity 7.9 kilometer per second actually. So it started revolving around the Earth's surface before falling onto the Earth's surface, and when it starts revolving, it eventually what happens is that it revolves around the Earth's surface, right? So first of all, it follows which path it follows. It follows the parabolic path. Then when it increases the velocity, it follows the elliptical path, and then again it follows the elliptical path, right? So firstly, it fired with 10 kilometer falls toward the Earth because of gravity. Then it's thrown with 30 kilometer, as I said. Then at a distance, when the ball is thrown with 7.9 kilometer per second, starts rotating cause of the gravitation of the friction acting on it. Okay, so this cannonball, we can take it as a satellite. The satellite, the case of the satellite is same as it, and now we could say that actually this 7.9 kilometer per second is actually the critical velocity. You know that this is a critical case, so this is basically a critical velocity. Now, what is critical velocity? Yeah, let's just write it. A velocity, a minimum velocity needed for a body, given to a body, to rotate around the earth, to rotate in a earth around the earth, to rotate around the earth. This is the minimum velocity given a body to rotate around the earth is known as where is the pen? Just right there. To the grave. Wait. Okay, so that's it. So a minimum velocity given to a body to rotate a hmm. So this is basically a minimum velocity given to a body to rotate around the earth is known as critical velocity. And this velocity, for example, let's erase this mass. So we'll discuss it here. Okay, Lynn mass picture as one, but that's fine. Let's bring it here. Let's discuss it. Everything is good now. That's fine. And now let's discuss it. Where we got another picture. So bring it here. Hmm. This velocity, which means the velocity which was here, is known as this is known as launching velocity. Launching velocity. This velocity is known as launching velocity. Launching velocity. And this velocity through which it rotates around the earth is known as critical velocity. This is critical velocity. Critical. And it's very much it's very unique to know that the critical and the launching velocity both are same, which is 7.9 kilometer per second, which means that we know that the no air resistance or gravitational field is acting upon it for a while considered, so it's moving. The critical velocity and the launching velocity both are same. In the next video we're going to discuss about the next concept, which is actually the satellite, the formula of the it's actually a formula of through which actually prove we will going to try the formula of this through which we have gotten this value. Yeah.